Hello everyone. I'm Sam, from the Lacially Intelligent Maintenance Service team. Today we're talking about the stacker crane's rails. The rail is like the stacker's running track. If the track isn't flat and straight, the stacker shakes and drifts as it runs, and in bad cases that causes positioning errors and failed storage retrieval. In this episode, we'll systematically walk through how to assess rail wear, how to judge accuracy, when to replace, and how to accept the work afterwards. On this episode, we'll nail down 4 things. First, why rails wear and what the consequences are. Second, how to measure rail wear with what tools and how. Third, at what point you should replace it with clear criteria. Fourth, the replacement workflow and acceptance requirements. The stacker has 2 rails, the floor rail and the top rail. The floor rail sits on the ground and carries the stacker's full weight, so it wears the most. The top rail is at the top of the rack, mainly for guidance and anti-tipping. The accuracy requirements are high, straightness and levelness within 2.5 millimeters over 3 mil, and the joint step no more than 2.3 millimeters thinner than a hair. You might ask why the accuracy needs to be this high. Because the rail is the stacker's running datum. There are 5 main wear modes. The most common is rail head top wear. The travel wheels roll on it for years. The top gradually dishes down, and in severe cases goes wavy. Next is rail side wear, worst at the aisle ends, where the stacker starts, stops and accelerates and the side forces are highest. Surface fatigue spalling is dangerous. Cracks and spall pits appear. Joint offset is uncommon but must be handled immediately once it shows. Finally, in a humid environment like Vietnam, rust and corrosion can't be ignored. For example, rail corrosion speeds up noticeably during the rainy season. You've probably used most of these wear measuring tools. A vernier, a caliper, and a depth gauge are essential. One for top wear depth, one for pits. A level checks rail levelness. The wire and feeler method is simple but very practical. Stretch a 0.5 millimeters steel wire end to end, then measure the wire to rail gap every meter, and the straightness is obvious. I recommend a fixed measuring point every 3 ms, so the data is comparable over time. So at what point should a rail be replaced? There are clear criteria. Top wear, no more than 3 millimeters for light rail, 4 millimeters for heavy rail. Side wear no more than 2 millimeters. Pit depth no more than 1 millimeters. Remaining rail head height must not drop below 70% of original and here's a 4-level scheme under 50% of the limit. Routine inspection, 50-80%. Prepare spares over 80%. Replace within 3 months. At the limit, stop and replace immediately. So when must a rail be replaced? Remember these 8 situations: wear at the limit, cracks, spalling over 1 millimeters, wavy wear causing stacker shake, rail deformation, joint collapse, repeated wear in one spot, and settlement that makes leveling impossible. Normal life is roughly 8 to 12 years for the floor rail, and 12 to 15 for the top rail. But that's only a reference B-ways. Go by measured data, and a survey every 6 months is most reliable. Rail replacement goes in 3 steps. Step 1. Preparation. Confirm the new rail type, get the tools ready, and park and secure the stacker. Step 2. Remove the old rail, loosen bolts. Remove section by section, clean the base. Step 3. Installing the new rail is the most critical. Start from one end and install section by section. Leave a 2-4 millimeters expansion gap at joints with a step under 0.3 millimeters. Many levelness and straightness after each section. Don't wait until everything is installed to find a problem. There are 4 ways to adjust the rail during installation. The most common is shimming, stainless shims under the rail. At most 3 per point, total under 5 millimeters. Clamp and set screw adjustments fine-tune the position. If the base itself is bad, you must repair the base first. One thing to stress is the joint. It's the weakest point, so use a dedicated alignment clamp and set the expansion gap to 2-4 millimeters depending on temperature. Remember the principle: course adjust first, then fine-tune everything together once it's all installed. So, well, how do you accept the rail once it's replaced? 6 geometric checks: straightness and levelness within 0.5 millimeters, over 3 mm, top-bottom rail alignment, many a 1.5 millimeters, joint step under 0.3 millimeters, joint gap 2 to 4 millimeters, and bolts firm. Measuring dimensions isn't enough. You also run the stacker. A low-speed pass first to listen for noise, then mid and full speed, and finally no-load and full-load storageless triple tests. And within all of it passes, is the acceptance complete. Daily rail maintenance also fits a 4-step method. Look and check the rail for abnormal wear, joints for offset, bolts for looseness. Listen for noise as the stacker travels, especially over joints. Feel wear a noticeable step at the joints. Record ALSPA's measurements and build a wear trend file. Once these habits stick, many problems get caught early. Rail lubrication is a skill. First, a key point: what you lubricate is the guide face, the rail side and the wheel flange. To reduce side wear, the running top surface must stay clean and dry, and must never be greased, or the travel wheels will slip and positioning will drift. Follow the OEM manual for the specifics. There are manual and automatic methods, and applying is fine for short rails, while long rails are better served by an auto lube system. Many of you may fear as paint the surface before lubricating. Otherwise, dirt plus grease becomes a grinding paste that speeds up wear. Control the amount too. A thin film is enough. And a rule of thumb: under-lubricate rather than over-lubricate, because excess grease gets carried everywhere, traps dust, and wears things faster. Remember, more is not better, and not every surface should be greased. Here's a real case. After 6 years, an ASRS stacker kept missing positions. At the same row, it would sometimes store fine, sometimes drift a few millimeters left. They replaced several address sensors with no luck. In the end, the cause was 3.5 millimeters of wear in the middle section of the rail. The rail had dropped, so the stacker dipped slightly there, and the sensor's angle changed. Note: 4 sensors in 3 months didn't help, because the root cause was the rail, not the sensor. The lesson: when positioning goes wrong, don't just swap the sensor, check the rail first. Let's recap the key points. 6 of them. First, the rail is the stacker's track, and accuracy is everything. Second, do a full survey at least every 6 months, and keep a wear file. Third, use the 4-level criteria. Well, don't wait for a breakdown to replace. Fourth, joints are the weakest link, so install them with extra care. Fifth, lubricate moderately. A thin film is enough. Sixth, and most practical: when positioning goes wrong, check the rail first, don't rush to swap the sensor. Remember, the rail is the datum, and if the datum is off, nothing else works. That's it for this episode. Today we covered rail types and functions, wear measurement methods, accuracy criteria, the replacement workflow, and acceptance requirements. Next episode we'll talk about the stacker's wire rope and chain. These are core components of the hoist system, and once they fail, it's a serious safety incident. Before wrapping up, let me make a brief business pitch. Leshy Vietnam team is dedicated to serving Vietnamese enterprises, providing professional and reliable logistics, automation, equipment maintenance services. We are rooted in Vietnam with a complete local professional service team. Whether you need long-term maintenance cooperation or emergency repair, feel free to contact us anytime. Thanks everyone. See you next time.